So I mentioned water pollution locally in Santa Monica and the state of California due to agriculture and Flint, Michigan. And wherever we are, water pollution affects us. So in the US, it's estimated that half of all lakes and a third of all rivers are too polluted for swimming and fishing. This includes the Los Angeles River and also the Santa Monica Bay on certain days of the year. And so if we have just a fraction of our water on Earth is drinkable, then it's so important to make sure that that water remains clean and unpolluted. As in the US, we had the Clean Water Act in 1972 that allowed for the government to control the contaminant levels in water. And continuing forward, the Safe Drinking Water Act in 1974 pushed that to more regulations on municipal water sources so that we have free drinking water available to all citizens. And so we will talk about bottled water in the next chapter, which is not regulated and which is in comparison to municipal free tap water that is regulated for pollutants. Just as with air pollution, we all contribute to the sources. Even though you think I don't purposely pollute any air or water, it's because of the stuff that is made, the stuff we buy, the food we eat, that the production ends up producing pollutants. So we can each also individually help solve the problem of water pollution. So what can you do? Well, one thing is just use less toxic chemicals whenever possible. Or if you have toxic chemicals, it's considered hazardous waste. So household chemicals you have that would be toxic and should not be entering the water system are paint, oil, and prescription drugs. So paint needs to be disposed of properly. If you have a giant can of paint from painting your room or your house, or even small containers of paint because you're an artist, anytime you can use water-based paint, that would be the less toxic option, and that's fine to dispose of anywhere. But if you have any type of paint that is not water-based, this needs to be considered hazardous waste. And so the other things are oil and prescription drugs. These are considered chemicals that need to be disposed of in something like a medication disposal like this, or taken to a toxic waste drop off. In green chemistry, it's better to prevent waste than to treat waste or to clean up waste after it's formed. How do we use water in the United States? So we can see on the x-axis, this is the years from 1950 to 2010. And then on the y-axis, the billions of gallons of water used per day. And so this is the public supply. You can see is kind of steady through the years. That's the dark blue bar. And then the green is irrigation. So that's irrigation is for food. So this is about 30%, this green, which is gone up, but is pretty stable. The largest number is this, the yellow. The yellow has gone up a lot since 1950. So here's yellow up, 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 up. The trend is up and it stayed high. And that's thermoelectric power. So that's electricity. That's producing electricity, 25% of the total withdrawal. And so you can see that this is what I called virtual water, is you can't see the water that's being used for the electricity. You can't see the water that's used for producing the food we eat. So whether you're vegetarian or flexitarian or a meat eater, this is all irrigation, which is used to water plants and crops that are fed to animals. So that public supply is about 12%, and that has remained stable, and that is your household water is not actually part of what's seen in the irrigation and generating electricity. So that's part of your water footprint, is the virtual water usage. So water is needed to produce food, and water is needed to produce products. Water is needed for stuff. So looking at this and thinking about the resources that went into your food and your stuff. For instance, looking at if you are strictly vegetarian, you can see that how much water is needed 1,200, 1,800, 2,100 liters of water just to make 1 kilogram. That's about 2 pounds of corn or 2 pounds of wheat or 2 pounds of soy. A lot more water is needed than the 2 pounds. But on the whole, all of these are the meat sources, that how much water is needed for chicken, pork, meat, and beef is 3 times or 10 times more for all of these meat sources, that water is needed compared to the vegetarian sources. And so this is because water is used to grow the corn and the soy and the wheat that then is fed to the chickens and the cows. And so this is a double source of water because you need to grow the food and you also need to give these animals water. So for products, one thing I look at most commonly is a cotton t-shirt. You don't realize the water that goes into making just a standard cotton t-shirt. So that's 2,500 liters of water that are needed for one cotton t-shirt. And that's because cotton is a plant that needs to be grown and watered throughout its lifespan, so that then you can pick the cotton and use the cotton, which also has to be processed. That takes a ton of water. And so it's something to think about, is the virtual water that is required to make food and to make stuff. So the US average is about 100 gallons per day of household water that's used. But that, of course, doesn't reflect the stuff we buy or the food we eat. So on this slide, we can see a comparison of the countries per capita. So that's per person. And as expected, the US has the highest overall consumption, overall water footprint. So that's about 2,500 liters of water per person per year. And it's broken down into the food. So this is red is food, and the stuff is industrial goods, that's yellow. So food and stuff is the majority of the water, compared to green, this is the household water, the domestic water consumption. And so other countries like Nigeria, this one is all red, so it's all just agriculture, it's all just for food, and it's less than the US. One country to compare with a similar lifestyle is Japan. So I don't think they're suffering in Japan. They're living quite nicely there, as we do in the US. And their footprint is almost half of our 2,500. It's just a little bit over 1,000. And they're still having the food, agriculture is half. And the stuff, the goods, the stuff they buy is half. And the domestic water, the household water, is even about the same. It's possible to have the same lifestyle, US compared to Japan, and yet use a lot less, or half the amount of water, by changing your diet, the food you eat, and your consumption, the stuff you buy. And so back to countries in Africa, so Nigeria again, is the average African has just about 1 to 2 toilet flush volume of water per day. And that's for everything. That's for their drinking, for their washing, and for their sanitation. And because of water accessibility, the water that they have is usually brought in from a river, and has to be walked in from a river because of lack of infrastructure. And that's usually walked in by women.